We acknowledge that we were founded on the traditional territory of many nations, including the Haudenosaunee, the Anishinaabe, the Attawandaronk, the Mississauga and Mississaugas of the Credit First Nation, and now live on land that is home to many diverse First Nations, Inuit, and Métis people. We have many representatives working across this land now known as Ontario, and we acknowledge that there are 46 treaties and other agreements that cover the territory. We are grateful to be able to work and live on this land, and thankful to the First Nations, Inuit, and Métis people who have cared for these territories since time immemorial, and who continue to contribute to the strength of Ontario and to all communities across the province. To continue to center reconciliation, we encourage our team, partners, students, and teachers to take time to learn about the lands they are currently on. Visit native-land.ca for more information.
All right. Hello, everyone. Welcome to our Pollinator Week virtual field trip. I'm Madison from Eggscape, and we're glad that all of you are with us today. So we've got something really sweet lined up because today we're learning all about honeybees and Ontario pollinators. So a lot of you might have been learning about this week already about pollinators, but just so you know what they are, they're special little helpers in nature, and they move pollen from flower to flower so plants can grow fruits and vegetables and seeds. Without pollinators, we wouldn't have many of the foods that we love to eat, like apples and berries and even chocolate. So on our past virtual field trip to a cocoa farm in Costa Rica, some of you might have been on that one, we learned something amazing, that the only pollinator that helps grow our chocolate or cocoa pods, the fruit used to make chocolate, is one insect, the mosquito. So they are good for something. All right, so today we're going to learn all about Ontario pollinators that help our local plants. We're going to meet Dave, a beekeeper that works for Backed by Bees, which is a business in Burlington, Ontario. And he's going to tell us all about Ontario pollinators, and then he's going to show us all about honeybees and how they work together to make delicious honey. So just a heads up for those of you that don't know, we're doing a Pollinator Pack giveaway. So to enter, please take a photo of your class participating in Pollinator Week and enter it for a chance to win some delicious honeycomb from Backed by Bees, as well as some other things like wildflower seeds. As always, put any questions you have in the chat. Dave would love to hear from you and what you're curious about. And without further ado, here is Dave. All right. So I'll let you introduce himself.
Thank you guys for spending some time on Thursday here with me. I'm Dave, the beekeeper at Backed by Bees, and you're lucky enough you even have Vincent, the mead maker, the guy who takes the honey and makes some amazing things out of it, behind the camera as well. But we're here at Backed by Bees, really cool. This is a pollinator farm, so we specialize and we love honeybees, and we're going to actually go see some today. But we're really about supporting all pollinators out there. They're also key for all the different things that we eat, the flowers that we love, and just making sure that roots stay in the ground and keep the planet healthy. And so we have our pollinator arch. This is the start of our pollinator path, and it's really the start of our journey when it comes to learning about pollinators so that we can actually partner with them and figure out how we can work and just make the world a better place. And so the really cool thing is most of us mainly just think about bees as pollinators, but there are so many different pollinators out there. We have birds, bats, butterflies, moths, beetles, flies, even though we don't think of flies as pollinators. And the cool thing is believe it or not, you guys are pollinators as well. And so we're not going to pay you like we'll pay the bees, because you're not as good as a honeybee when it comes to pollinating. And the main difference, although there's a lot, is honeybees are so darn good at pollinating because they actually have really hairy eyeballs. And so what makes a bee a great pollinator is when it gets its head right into that flower, it's sucking up all that nectar, it actually gets covered its entire body with pollen. And when it comes back to the colony, it clears all that off and then stores that as pollen. Some of that pollen might actually go to another flower as well. So we're gonna head back to the honeybees, but really cool, what we also do here is we work with a whole variety of other different pollinators. If you guys like Niagara peaches, you guys can thank bats, believe it or not, for helping out. And so bats, they do a special kind of pollination where late in the evening, the bats will go and they'll try to actually eat bugs that are in some of those flowers, collecting some of that nectar. And because they're so hairy and so fuzzy, they'll pick up a little bit of that pollen. And when they go to eat the next bug at the next flower, some of that pollen might fall off. And so they do an act of pollination, but they just don't mean to. But Niagara peaches actually do benefit from bat pollination. We just went through Birdland. There's some pretty amazing birds. One of our most popular bird pollinators in Ontario is going to be the ruby-throated hummingbird. If you have vines, so trumpet vines, clematises, wisteria, things like that, those little hummingbirds love to get right on in there. They have a nice long beak, and so they can get into those deep flowers, and when they're in there, they're just like a honeybee. They actually get their faces all covered with pollen, and then when they go to the next flower to sip some of that sweet nectar, some of that pollen falls off, and they're able to pollinate those flowers by doing that. So huge number of pollinators out there. The one I think most people don't realize is actually the second biggest and the second most efficient, let's say, class of pollinators are these guys right here. So moths. We tend to not think of moths as really great pollinators, and it's because we tend to not see them. I mean, moths own the night. They own the shoulders, the dawn and dusk, and so they're out there doing all that great pollination, all that work, when everybody else is in bed. And so, almost did that. So when we talk about being in bed, because it's not the greatest weather day out here, it's not a lot of bee flight. These bees, with the weather that we've had, we had a lot of heavy rain last night, some big thunderstorms rolled through, and what ends up happening when you get a lot of really large water droplets, some really heavy rain, is, believe it or not, all the flowers will actually close up their nectaries for the entire day, about 24 hours. So even if we were out here and the sun were to break and it became a beautiful day, the bees aren't actually going to pollinate anything today. They're not going to be making any honey. And so we don't see very many bees in the air, but when we go into these colonies, everybody's going to be home. So it's a great day to go in as a beekeeper, see how these bees live, see how these bees work, because we're going to see just about all of them. And so behind me, the cool thing is what you guys are seeing today is a full commercial honeybee yard, or if you want to get fancy with it, we call this an apiary. So it's quite often confused with birds, which we call, areas where birds are aviaries. But this is an apiary, and it's easy to remember because that P ends up looking like it's got a little stinger on it. And so that's how you can tell the difference between these two. But where we're standing right now, no joke, there's probably 2.5 million honeybees around us right now. And so we're going to go into a colony. I would love to show you guys what the inside of a honeybee colony looks like. But in order to do that, we got to keep ourselves safe. So come on over. And I'm going to show you two of the things that beekeepers are always using in order to keep ourselves safe. Now, you guys might be used to seeing beekeepers wearing those big white astronaut suits. And now, on a day like today, where it's only 20 degrees, I might be okay with getting away with that. But on a 30-degree day, or like next week when the Weather Network's calling for 45-degree weather, there's no way most of us would enjoy putting on that big, heavy, sweaty suit. And so what beekeepers nowadays wear is our safari hats. Now, this is a hard hat, so it doubles as a safety hat in case, like you see above us, most of these beehives are underneath big trees. So we just want to protect their head in case something branch falls off the tree. And the other thing we wear is what we call a veil. And this is really important because now bees can't get into our faces or anything like that. And it's really so that we can stay focused when we're inside that colony. Everything inside that colony is super small, bees, eggs, larvae. And so if you have bees buzzing around our face, it can be really distracting and really annoying. Now, it's distracting enough having this. It's going to be hard to see you guys. I'm actually going to take that off. Just go ball cap for today. So that's one thing we wear. The other piece of equipment that we don't wear, but we bring with us, is called a smoker. Probably the most iconic piece of beekeeping equipment out there, and maybe one of the most misunderstood. The whole idea about why we actually use smoke really primarily is because inside that colony, they don't have windows, they don't have skylights, they don't have lights at all. It's completely dark. And so inside that beehive, they communicate almost exclusively by smells. And if we can cover that smell up with really strong smelling smoke, they can't communicate, they can't organize anything. And so we can stay in control in that colony. And then when we leave and close things up, they actually use their wings, they blow out all the smoke, and then business returns as usual. The only funny one when it comes to bees and smells is what you might not know is beekeepers are weekend-only banana eaters. And so the bees actually can't tell the difference between us smelling like bananas and them raising the alarm and getting ready for an attack. So today, if we're out in this bee yard and Vincent smells bananas, he might take off and run, and I'm going to be right there with him. So it's really windy. We'll see if we can get this lit. But we need to get a good fire started. Oh, we almost had it. There you go. And what we don't want to do is actually leave this fire lit. Oh, we're going to try one more time. Because if we leave that fire lit, we're going to start flame throwing these bees. And the reason why they're such great pollinators is because they're super hairy. So the last thing we want to do is burn off all that hair. So we're going to get that started. We always make the joke that no good beekeeper has any hair on the back of their hands because we're always dealing with fire and these smokers. And once we have a good base, we're going to start using pine shavings. Now these pine shavings, the cool thing about them is when they burn, they actually burn fairly cool. So I can put my hand right above that. And if my hand's going to be safe, I also know all my honeybees are going to be nice and safe. So we got our smoker going. And so what I'm hoping to do, what'll be really cool, is if we can open up this beehive and let's see if we can find a queen bee. Now, I'm going to take it easy on myself. We have a couple of hives here that are really new young colonies. So they're not really, really big. So it should be fairly easy to find the queen bee in one of these guys over here. So come on over with me. We're going to go into the Met's house here. And what we're going to do is just puff a couple of puffs of smoke right into the entrance of that colony. So any of those guard bees there get that smoke, and now they can't go in and communicate to everybody else that, watch out, somebody's coming in. This top box, we're going to take off. And now we can see, so a fairly young colony, I'll talk about this piece of equipment in a second, fairly young colony that's only really taking up about 4 frames of these bottom 10 frames. So going to be really easy to find the queen bee because I'm only going to have to search through 4 frames to find her. And so this is what a frame of honeybees looks like. So you can see underneath there all the honeycomb. And there's a variety of different things. All on this top here where my fingers are, this is all going to be honey. So the bees store the food around their brood chamber, around their young bees. Excuse me. So that is really easy to take the food from over here and feed it to their young right over here. So you can see right in underneath here those white glossy things. So Vincent's going to try to catch those. Those are all larvae. And so when bees actually are larvae, they don't look like bees at all. They look like little white grubby things. And then when the bees go through and pupate, they go through metamorphosis, they put this wax capping on that. And so that, it just looks like brown paper bag, like what you would take your lunch into school. And underneath there, there's bees developing and they're starting to grow their eyes, their wings, their legs, every body part. They actually, the cool thing is some of the cool, like the numbers when it comes to those, bees actually have 5 eyes. Most people only think 2. Bees have 4 wings. They have 2 sets of 2 wings. And when it comes to their antenna, they have about 1,400 different receptors in those antennae. Now, most of the bees that we're seeing here on the frame, excuse me, I'm choking on smoke, are all going to be worker bees. You can see they pretty much all look the same. They are kind of long and pointed, so they do have stingers at the back of their bodies. They're all inside, so we won't be able to see them. And they have 2 very defined eyes. Now, if we contrast that, and I have a special bee in my hand here, I have a boy bee in my hand. And we can tell the difference between a boy bee and a girl bee because his eyeballs go right around the entire top of his head almost. You can see those big, big eyes, and he knows he needs those really big eyes excuse me, in order to find the queen bee flying around in the air. The other really cool thing about these guys is, believe it or not, they taste good. I'm kidding. They actually don't have any stingers at all, so you can kind of play around with them, and he's just going to be late for a date.
Dave, this is awesome so far. Thank you so much for showing us. We have a lot of questions. Do you mind answering some?
Yes, why don't I'll keep looking for the queen and multitask, and feel free to fire away with some questions, and I'll answer them in the meantime.
That sounds great. All right. Our first question is from Grace. Is there a queen bee in each hive?
So there is a queen bee. There's the mom of every family. And when we scan out over this yard, each one of those stacks, each one of those towers is going to be one beehive or one bee family. So there's one queen bee. Doesn't matter how tall it goes, but there's one queen bee in each of those colonies. Yes.
Okay, awesome. Aubrey's wondering,
Yes.
what happens if the queen bee dies?
So the cool thing is about honeybees is the worker bees and the queen bee are all girls. They're all females. So they come from fertilized eggs. If we made a big mistake and we squished a queen bee today, the bees would go on a hunt and they would try to find 3-day-old larvae that were going to be worker bees. And what they would do is instead of feeding them honey, they would shift them onto a diet of royal jelly. And so royal jelly is basically just better food, more nutritious food for the bees. And with that royal jelly, those bees are going to develop a little bit further. They're going to develop into queen bees. And that's how they make queen bees. So they're just better fed worker bees, essentially. Now, the cool thing is once you have a queen bee in that colony, she's walking around laying down a chemical that stops all these other worker bees from getting the idea that they should become queen bees. So she's in control that way.
Right. That's very cool. Okay, we have a question. How big can the queen bee get?
She can get pretty big. I'm hoping to find one. She's not putting up her hand in this colony, so we might jump quickly over to one other colony and find her really quick. And she's not going to be like a termite queen where she's like 5 times larger than the worker bees. She's going to be ever so slightly bigger. And the only difference is because her ovaries are fully developed, she's going to be a little bit bigger. We're going to jump on.
Isabella's wondering, if there are no queen bees, why does queen bee?
Well, there are. So inside of each one of these colonies, there's no such thing as a king bee, but there's lots of boys. And so there's one mom in this entire colony. One queen bee lays all these eggs. The boys, there's actually about anywhere from 80 to 90 different dads inside one of these colonies. Excuse me. And we have a queen bee on this frame. And so the big challenge is for Vince to actually follow her. But if you look at her running around over here, she's this bee. She's not that much bigger than all the other workers. She's just longer. And I'll pick her up in a second. I just want you to see her crawling around. So you can see her crawling around at the bottom. And again, because she's a girl, she has the same head, the same shoulders, the same thorax as all the other workers. It's just that abdomen that's a little bit longer because she has to lay about 2,000 eggs every day in the summertime. So we're going to pick her up here. And what's so cool about her, I'm going to show you. If you look really close.
Sorry, I'm just wondering, could you maybe refresh your feed and rejoin? I think it might be clearer. And then it's just a little blurry right now.
We'll quick do that. You bet.
Perfect. All right. Okay, so while they're refreshing, I'm hoping it's clear so we can see it a little bit closer. I just want you to talk with your class all about pollinators, any that you've noticed, and oh, looks like they're back. Just kidding.
Vincent's ass on the phone.
You're good. So now, oh, it looks great. Okay, keep going.
So if we look really closely at her, the cool thing with these queen bee is you might actually be able to see her abdomen, or basically her tail end, or her butt, actually pumping it away like an accordion. And so because they're bigger, we can see that, and that's actually how she breathes. So she's going to pump that away, and as she pumps that away, that's how she breathes. So that's why we joke, we can put all these queen bees in headlocks because their mouth isn't actually attached to their lungs. We don't stop them from breathing, and they're pretty happy in that sort of position there. So that's as big as the queen bees are ever going to get. They're not going to get any bigger. So they're slightly bigger than the worker bees, but not 4, 5, 6 times bigger than the worker bees. So we're going to put her back. And away she goes. She's down. So she hates sunlight more than anything. She lives her entire life in darkness. So when we pull her out like that, excuse me, and then we put her back into the colony, her first instinct is to dive right on down and get back into the dark parts of the colony. Now this is cool. So this is actually what beekeepers use in order to keep honeybees on frames inside that colony. So what you can see is this black, what we call foundation. And so you'll see the little black honeycombs. We give them this pattern. And if you're in Ontario, the cool thing is it's actually law that we have to give them these frames as foundation. We have to be able to remove frames from this honeybee colony because all day long we have to be able to inspect them to see if we have diseases or pests or things going on in the colony. If we don't, the bees are going to build something that looks amazing. It's going to be organized to them, but chaotic to us, and we won't be able to investigate what's going on deep within. So we had a brand new frame. You can see now the bees, what they go and they do is they produce a lot of wax. And within no time, within a couple of weeks, this whole frame is going to have that honeycomb wax, just like the other frames we saw. And that's how they actually grow the colony. They just keep laying down more foundation inside that colony. So let's talk about this next one. So the cool thing is, so you saw in that last frame when we were over in the other colony, we have beeswax, we have honey, we have young, all in those same frames. And so it can become a big task if we were to take out that frame. How do you take out the honey without adding bits of bees into your jar of honey at the end of the day? And so way back when, beekeepers invented this really cool piece of equipment. It might not look that special, but this is special to beekeepers, and this is called a queen excluder. And so you should be able to see all those metal grates, and those holes are big enough that the worker bees can go through. So you'll see these girls, they'll pop back and forth, but the queen bee, because she's a little bit bigger, and the boy bees, because they're bigger, cannot go through this. And so if we put this on, so we know the queen is down below. If we put this on top of that colony, now any box we put on top of this, we know the queen can't get through here. And so all that's going to come through, there's no eggs, there's no larvae, no pupa, the queen can't get up there. So that means these boxes are going to be entirely used for honey. So these are called honey supers. And so in the summertime, again, behind Vince, we have 3, 4, 5 boxes on some of these colonies. So they start to grow and they start to get really, really big. The most, like the largest bee colonies will actually max out around about 80,000 honeybees in a typical colony. And so they'll get as tall as me. I like to think I'm 6 feet, but they'll get as tall as me, 6 feet tall. And inside those colonies, they can actually produce in 1 year about 300 pounds of honey. Now, they eat through about 200 pounds of that. That's what they eat. They need that. And then they have an extra amount of about 100 pounds. And that's what we're able to take. So the trade-off a long time ago when it came to working with these pollinators is we keep them safe. So that means if there's skunks, bears, let's say there's forest fires, let's say there's things that are going to threaten our honeybees, the beekeeper, we keep them safe. We move these boxes, we take care of pests, and in return, what we get is that extra 100 pounds that the bees were just going to kind of have inside the colony anyways. And so that's how we're able to work with these pollinators. Now, the cool thing is, if you look behind us, this bee yard here, and what's so great about the environmental impact is these bees are going to work on any flower within 5 kilometers around this yard. So they work on all the different hay farms and cash crop farms and down in the creeks and the riverbeds. They help pollinate all those flowers there. And in return, in this yard alone, on a fantastic year, and I'm hoping this is a great year, we'll be able to produce about 2 tons of honey right in this bee yard alone. So it's really, really impressive what these bees are able to do just using this as home base. And so what we're going to do now is we're going to close this beehive up. So you can see these bees, they're not loving this weather. If we do a scan down and you look down in between these frames, what you're going to see is all these bees with their head looking up at us. And that's like, I like to think it's like the start of the Kentucky Derby. So it's all these bees that are ready to rock and roll if something were to really tick them off. Let's say we made a really sharp movement or we ate a banana in front of them. All these bees are ready to go and they're ready to attack if they need to. And so what we're going to do here is we're just going to close this colony on up, put our handy queen excluder back on, and let's see if any of these colonies have brought in any honey yet. And so because that's a weaker colony, it likely won't have. So let's go to a big colony and see if they've been able to put some on. So we got a bigger colony here. So this one's almost at chest height. Let's see. These bees haven't either. We'll go to one more colony and see if we can find some honey for you guys. let's head all the way over here. I think I have a good colony over here. I'll go inside this colony. Yes. And so we just put these honey boxes on just the other day. Awesome. And what we're going to see is inside these honeycombs, if we look down deep in here, what you're going to see is you're going to see a liquid. Now, what most people think is that bees actually go out and they collect honey. But believe it or not, these girls don't collect honey at all. They actually go out to the flowers and they collect nectar. And so right now, the biggest flower these bees are working on is this white Dutch clover. And you'll see it in all the soccer fields and in your yards right now. So this is a great bee crop. The bees are working on this and they're bringing it back. And the nectar that comes off this flower is actually about 80% water. It's mostly water and only a wee little bit of sugar. And these bees actually have to take most of the water of that. So they have to take it from 80% down to about 20% in order to keep honey stable for a long, long time. So if you come back to the frame here, what you're going to see is you're going to see these bees with their heads inside the cells drinking honey, drinking that nectar. At least that's what it looks like they're doing. But what they're really doing down in there is they're sucking up little bits of nectar and spitting it out, sucking it up and spitting it out, sucking it up and also puking it out. And that process is what takes a lot of the water out of that nectar, but also it adds a lot of their spit. And so honey is actually really nectar from the flower and then a lot of bee spit as well. And the bee spit does some really cool things to that honey in order to keep it shelf stable for a long, long time. And the coolest thing that with their spit they can do is they actually make hydrogen peroxide. So that stingy liquid that you might put on a cut in order to keep it nice and clean, they produce that inside their honey. So that inside your jar of honey at home, it's actually keeping itself clean all day long. And so why we don't have to worry about this product being out in nature, whether it's raining or a nice sunny day, is it's protecting itself all day long because these bees are spitting up in it all day long. And so that's what they're really working on right now, is they're trying to take up on honey. So let's put that.
Goodness. So you're telling me we're just eating bee spit.
You are eating a lot of bee spit. Yes.
That is hilarious. We have a lot of questions in the chat. Do you mind answering some of them?
Let's answer some questions. Yes, absolutely.
Perfect. All right. How long does it take for a bee to develop?
So bees go through egg, larva, pupal, and then they turn into adults from there. There's 3 different time frames depending on whether you're going to turn into a worker bee, a queen bee, or a drone. And so a worker bee goes from egg to adult in 21 days. A drone bee, a boy bee, he actually takes 24 days because he's a little bit bigger. And so the queen bees, because they're fed such really good nutrient-rich food, royal jelly, they actually develop really fast, and they can develop within 16 days. And so that's how long it takes for a bee to go from egg to adult.
Wow, 16 days. That's quick. All right. We're wondering, how long does it take for the bees to finish making the honey?
So that really depends on how many bees are there to actually process that, and also the temperature. And so you guys might not be happy about 45 degrees coming next week, but as a beekeeper, I can't be any more happy about it. I'm really thrilled. And so these bees, believe it or not, they actually have their own form of air conditioning. And how they air condition and cool down this colony is actually go out, they collect nectar at 80% water, a lot of water. They come back to the colonies and then they evaporate off water. So just like you guys sweat, you guys are taking water out of your system because there's lots of heat in that and leaving that out there. The bees do that as well. So on a really hot day, they can actually produce about 4 to 5 pounds of honey in that one day, that one hot day. So on this honey, it's so hard to tell. I couldn't give you a real answer as to whether it's going to take 1 day or 2 weeks. It all depends on weather. It depends on how much nectar is coming into the colony. And then the other thing we're dealing with is, if you can remember, 2.5-3 weeks ago, we had really cold weather. We were almost wearing winter coats out in the bee yard. And so the queens, when it's that cold, actually stop laying eggs. And if you remember, worker bees take 21 days, three weeks to develop. So right now, what we're actually dealing with in these colonies is a population is somewhat declining because there's nobody hatching out as an adult. Because 3 weeks ago, the queens didn't lay any eggs. So it's going to take a little bit of time for them to ripen that honey because they're not growing as a colony until next week.
Right. That makes sense. Well, shaped the way that they are.
Pardon?
Why are honeycombs shaped the way that they are?
Aha! So I used to think all the time that bees were really smart and they knew that the honeycomb shape was one of the most efficient shapes. There's no waste because every corner actually touches another corner. But I finally got disproven, and bees, they're basically circular. So they actually lay down honeycomb shape in the wild in circles. And then because they keep the inside of that colony at 33 degrees, so just like a chicken has to incubate her eggs, these bees have to incubate their young, their eggs, and so they do that at 33 degrees. It's so warm that it actually takes those circles, it melts the sides, and so then it melts into that shape, because it's so efficient, into the honeycomb shape. So they really make circles, and then over time, they actually melt into that honeycomb shape, so there's no wasted space. So that's why bees make honeycomb shapes.
That is interesting. I never knew that.
Me neither, until about a year ago.
That's cool. All right, let's do maybe a couple more questions, and then I'm not sure, is there anything else you wanted to show us in the bee yard?
We could go forever, for sure. Yeah, there's more we can show you, for sure.
All right. This is a great question here. Are you immune to bee stings? You're not wearing any protective clothing. Or is it because you're wearing yellow, so you're one with the bees?
Either that or I look like a banana. Who knows? So believe it or not, as a beekeeper, one of the hardest decisions starting out is you have to decide whether you're going to get stung a lot or you're never going to get stung, meaning you're going to suit up every time you're around the honeybee colonies. Now, because I don't do really great when it's that hot and I'm that sweaty, I had to make the decision that I'm going to be okay with getting stung. So on a day of beekeeping, if I'm out moving around and doing a lot of work, I'll get stung anywhere from about 4 to 15 to 20 times a day. And your body develops an immunity to it. And so now, if I do get stung, it's a pinprick. You never get used to somebody stabbing you with a pen. But no heat, no swelling, no itch, none of that reaction comes anymore in our bodies. And so you do develop that immunity, and it probably takes about 2 years. So it's not a fun 2 years because you look swollen all the time and you're itchy and stingy. But after that, now it's just a quick little pinprick, and I'd rather take 4 of those a day than have to wear the full suit. And the other thing is these bees are actually being bred so that they will be a lot less aggressive. And so inside this colony, they all know we're here. They can feel Vincent and my vibrations from 7 meters away. So they all know we're here, but they're quite happy with us. These bees go to flowers and home. They're not wasps, they're not hornets. And so they're actually really, really nice to work with.
They're kind of like little pets now.
You are. So why don't we answer some more questions? I did want to show you one more really cool thing because we have some special colonies where we're actually raising queen bees. And it'd be really cool to show you guys what a queen cell actually looks like. So we're going to walk over and do that, and then I can answer some questions as we go here.
All right. So Lucas wants to know what happens if we have no bees?
If we have no bees, life is not going to be very fun. First of all, mom and dad are not going to have any coffee in the morning. So coffee relies on honeybee pollination big time. So they might get a little grouchy. But also, most of the food that we tend to really love, so most berries, seeds, nuts, produce, legumes, all rely on bee pollination. There's other pollinators that will help, but honeybees are the driving force behind a lot of that pollination. So you better get ready to eat a lot of corn, a lot of wheat, and a lot of potatoes if we were to lose honeybees. And I think it's going to be very hard to keep that whole plethora of vitamins, minerals, and everything going into our systems if we're just relying on a few major food crops instead of our kind of main produce.
That's really cool. The honeybees are that important.
They really are.
Yeah, because we all don't want to just eat potatoes. We love potatoes, but, we want our fruits and our other items like that. Okay, we'll have one more question. Yes. What happens to bees in the winter?
So what happens to the bees in the winter? is they're actually not that different than us. They need to stay nice and warm. So they live outdoors in those boxes year round. So you could come out here in the middle of winter and you'll see bees in their boxes, and we'll insulate them to just help them out. But what they do is they cluster. So they get in so really nice and tight and close to their sisters inside that colony, and then they shiver. So just like a snake can unhinge its jaws so it can open its mouth out really wide to eat really big food, the bees can unhinge their flight muscles, those big muscles that control their wings, from their wings. And then they can use those muscles, big muscles, just like if you guys run, you get really hot. Those bees will get really hot if they use those muscles, because they're not flapping their wings. They're also not cooling down. And middle of February, it can be negative 20 degrees outside. Inside of each one of those colonies, it will be 33 degrees. So they don't fly out because there's no flowers to work on. But what they'll do is they'll be inside that colony, just trying to keep nice and warm by shivering. And so this year, what I wanted to show you guys was one of the coolest things, because queens come up a lot and we like to talk about queens. And so this is a special frame that beekeepers use in order to produce queen bees. And so on this, you'll see I have 1 queen bee, 2 queen bees, 3 queen bees, 4 queen bees. They're all inside their cells. And so they look like little peanuts that are dangling from these cell bases. And so what I was able to do a week ago, I was able to go into some colonies that I really like. Some really nice colonies that make a lot of honey for us. And I took 3-day-old larvae, and then I put them into this special colony here and tricked them into thinking they didn't have a queen. And because they didn't think they have a queen, they're going to try to raise a whole bunch of these. And so I have maybe 20 on this frame. And so my big job tomorrow, every Friday morning, what I do is I'm going to have to come in. I'm going to have to take these all apart, because if one queen bee hatches out, her first job in life is there can only ever be one mom. She's going to go around and try to kill all the other queen bees. So I have to take them out, separate them, and then I put them inside of all these little colonies. So you'll see all these little white boxes. These are baby colonies or starter colonies. And so some of them don't have queen bees. So I'm going to introduce queen bees to there. And that's how beekeepers actually make more honeybees, as we have to make up little colonies and then introduce queen bees to those bees from there. So we're going to put them back, because it's certainly not 33 degrees outside right now, and they have to keep those at 33 degrees. But that way, just in this colony alone, we're able to produce another 20 colonies every single week throughout the entire year. Well, throughout the entire beekeeping season. We're going to close that back up.
Very cool. I don't think I've ever seen that before, how a queen is truly hatched and made. That's awesome.
Most people haven't, yes.
That's so cool. Okay, so we only have about 2 minutes left. So
Okay.
why don't we just answer like 2 or 3 questions quickly, and then we'll fortunately have to say goodbye to everyone. This has been great, though. Okay, let's do it. Okay, so do all the bee colonies get along with each other?
No. So bees will actually drift, and they will somewhat fight amongst themselves. And which is why in this area, in southern Ontario, in Halton region, we can really only keep about 30 colonies every 3 square kilometers, because there's enough flowers that times are good and those bees don't have to fight. If we started dumping 50, 80, 100 colonies, they're going to really start to fight over those resources, and that can be really bad. They also, each one of these colonies has its own unique smell, just like we have our own fingerprints. They all smell different. And so if one cis or one bee comes from another colony, she doesn't smell like home, they're going to fight and they're going to kick her on out. So there's bees that stand at the front of the colonies, and they're guard bees, and they'll kick out bees that don't smell like their sisters.
Oh, goodness. The whole kingdom. Okay, another question. What do you do to stop the bees if they fly far away?
Sorry, I didn't catch that last part.
How do you get them back if they fly too far away?
Well, unfortunately, we just can't do that if they get too far away. So we're the only farmers out there, I like to think, in Ontario anyways, that don't have any fences. And so we just hope every night that all our bees come home. But the idea behind bees is the queen's laying 2,000 eggs every single day. Those colonies are going to get up to 80,000, because inevitably we're going to lose a few. So the really cool thing about here, if we had more time, you know, what these bees really do for the ecosystem is amazing. They are bottom of the food chain and a food source for birds, bats, skunks, moles, voles, possums, all those different things eat these bees. And so we donate bees all day long to the ecosystem to be food as well. And so you can't save every single one. We just do our best, but that's how bees live, and that's what their role out in the ecosystem is.
That makes sense. Okay, we'll do one final question, and then we'll have to say goodbye. All right. How does the royal, oh, there's been a lot of questions about the royal jelly. So how does the royal jelly make the queen bee a queen bee, and how is it different?
So there's honey, which is just the nectar and bee spit that the bees, produce inside that colony. So they collect nectar, add spit to it. That's really high octane. There's lots of sugar in it, not a lot of minerals, no fat, things like that, no protein. And so the bees, you can think about royal jelly being like the milk of the honeybee. And so what bees do is they go out and they eat a little bit of honey and nectar. They'll eat pollen and they'll mix those things. They have a special gland inside their brain that mixes those. And now it puts a lot of protein, let's put a lot of fat inside that food, and they can spit that out onto the queen, and the queen rolls around and eats that all up. And so now you have a food that has a lot of protein and a lot of fat, and because it has a lot of protein, it's got excessive amounts of protein, which is pollen. It actually just allows the queen bee to grow that much faster. And so it's not milk that comes out of other parts of the body, it's milk that actually is produced in their brain and then fed to the queen bee from there. And so they just won't, that takes a lot of energy out of them. They're not going to produce that for just another little worker bee inside that colony. So they're just going to feed them honey in order to give them the energy, the sugar, to grow fast.
Amazing. That's so interesting. Okay. Well, we have a lot more questions that people have sent in. So thank you everyone for sending in your questions. Please either go to a local beekeeper or visit Backed by Bees if you want to get your questions answered. We really appreciate you all joining us for Pollinator Week. It's such a fun opportunity to learn about these important insects and especially honeybees. And we also learned that it's not just insects either. It's more than that in Ontario. So yeah, everyone keep celebrating Pollinator Week. I want to pass it over back to you, Dave. Is there anything you want to say to everyone watching before they sign off?
I'd say one thing here. My PSA is learn the difference between a wasp and a honeybee, because honeybees really are our friends. They provide a great ecological benefit out there. So the more you can do to support your pollinators in the backyard, plant a flower, don't cut down flowers in your local area. The more we can do to help these pollinators, the better the whole world is for all of us. So the better you can support all those pollinators, the better.
Absolutely. I could not have said it better myself. So yes, please keep learning. Pollinator Week's not over yet. Plant some flowers, do what you can. And maybe next year as well, you'll just be that much more aware of what you can do. Thank you so much, Dave and Vincent, Backed by Bees. This was amazing. We learned so much, and unfortunately, we got to go. So I hope you guys have a great rest of your day. Remember to submit your photos for the contest so you can potentially try some of the delicious honeycomb that you saw today. And yeah, all right. Have a great rest of your day. Bye, everyone.